Hello everyone and welcome into yet another live stream. I don't think there is much of a point with an intro because, well, well. Hi the Stamp, hi the Olo, hi the Adrian, hi everyone, welcome to the live stream. Hi the Weston. I cleaned up my apartment a bit today. This is a bit of a backstory for today's stream, okay? Just a bit. Just a fair little bit of a backstory. Remember how recently on streams I've been mentioning that I feel like I'm having a manic high, right? Well, you know what comes after a manic high? It's a manic low. That's actually the main reason why I cleaned up my office. I find it that when you have when you're crashing down mentally, having a clean space around you helps. So that's why I did that. Hence why I set my sink on fire. Long story. And before this live stream, I spent over an hour uploading a single image to my server just to make Bandit funny. So I am starting today's live stream exhausted and really just exhausted. Exhausted is the right word. So hold on, I need to plug in the camera. Don't mind. Let me just plug it in. This is gonna be a great one. I'm gonna have so much fun. Oh my goodness. Okay. Oh, the batteries in my camera are also both dead. Oh, poor planning and everything. I am enjoying myself so much. Ay. So much fun. Oh, never mind. It's 100%. I take it back. I've been complaining for nothing. See, that's what you get. That's what you get when you complain. When you complain, then life does everything it can to just prove you that you shouldn't complain. Anyway, I said, anyway. No, that was my Discord. That's the wrong add-on. This is the right one. There we go. It's not my Discord. Anyway, we need end the stream if you're tired, silly. No, I'm gonna show you what you do when you're tired. You want a tutorial, everyone? You wanna? Hello everyone and welcome into another Make It tutorial. Today I'm gonna show you what to do when you're tired. This is my coffee I have. Just a little bit, you know, just like a little bit. And then to top it off, you might think it would be bad, but actually a little bit of milk goes a long way as well. Ah shit, spilled it everywhere. There we go. See? Just a little bit. Then you mix. Oh yeah, that's the kick. My goodness, that is strong. You don't want to overdo it. I might have added a bit too much. You don't want to overdo it, but it really brings up the flavor, you know. Anyway, anyhow. Oh, I also need to get some water because I can't just be day drinking all the time. I should also drink some water as well. Hold on. Okay. So with that in mind, what are we gonna do today? I hear no one asking, and I'm so glad you asked. This is our Raspberry Pi. Hold on, because this is. Can I set it on fire? No, not for the percentage. Fine. I'll need to wipe it off then, I guess. Where's the US? Okay, so this is our Raspberry Pi Zero. This is our Raspberry Pi Pico. We've been trying to connect them for the entire last stream. Hey Maker, what are we doing today? I am so glad you asked, Weston. The sun has almost set, so it's not day drinking. Okay. Last time we tried connecting them with I2C, which apparently is a bust. Apparently connecting them with I2C is a really dumb idea, which I just simply didn't know. So today what we're going to do is we're going to... Oh, that's spicy. That's spicy. That is strong. We're going to try to connect Raspberry Pi to Raspberry Pi Pico RPI connection. That's what we're going to try to do. Because apparently RPI can be a bit better for this. Right? Zero connection between Raspberry Pi and Raspberry Pico. Okay, import bot. From bot import bot. That's... Bluetooth connection. That's such an awkward workaround. I could just pick a W if I wanted to. The whole point is that we'd want to do it hardware, you know? What's the difference between Pi and Pico? Oh, they're all different Pis. They're just different kinds of Pis. So, right here, from right to left, you have strongest to weakest. You have Raspberry Pi 5, Raspberry Pi 0, Raspberry Pi Pico. This one is the strongest, it can handle a lot. Then you have this one, which still can handle like visual processing and stuff. Well, simple visual processing. And you have this one, which wouldn't be able to even handle visuals. I'm sorry, I'm day drinking, so... Okay. No, just one more sip before we get to it. There we go, okay. Hi, the Tefta. Microcontroller versus CPU. Exactly, hi, the Tefta. Hi. What a perfect timing you have. Make it the microcontroller dealer. I have so many more. I even have this one that's like laying on my desk. Not even using it for anything. But yeah, if we connect these two together successfully, the toughest part is done. You sound the RPA is a computer system, and RPA Pico is just a microcontroller. Yes. Wait, am I... Hold on. First of all, let me try Raspberry Pi Pico Cloud. Am I thinking correctly of an RPI as a system? Or am I misremembering the words? There we go. Was RPI the standard for, or was it SPI? Oh, I might be an idiot. It might have been SPI. To RX, since Raspberry is still relatively young. Raspberry Pico is still relatively young. Oh, when was this written? 2021. Right. Okay. RPA is not overpriced. That is one of the main reasons why I like him. The whole like selling point of Raspberry Pis is that the microcontroller is $5 and the Pi Zero is $15, which I think is great. Raspberry Pi is overpriced in my opinion for the specs. Well, it depends on what your alternatives are, right? I really like Raspberries. I like them a lot. The Picos and Zeros. The 5 itself I did buy because I really want to integrate it as like the main thinking thing, but I don't like the actual big Pis, if I'm to be completely honest. I don't love these. I do like the Zeros and the Picos. The Zeros and the Picos are great. I adore them. Okay. The connections options. Wait, but actually, is there like a dedicated Raspberry Pi way before we go? Is there like a? This should be right. Using USB. I don't want to use USB. Not using I2C between devices otherwise meets your needs. What is it? Python previous. I can implement one myself, I guess. what's the very final goal of this? Or the very final goal is for me to take this mask right here. Actually, why am I showing you the mask like so? I can show you in SolidWorks. In SolidWorks it will be much easier to show, because this is actually, there's some people drag racing outside my window. This is actually the old model, and the new model is, I need to log into my SolidWorks. The new model is just a bit better, but the basic idea is that we want to have a mask where right here we'll have a Raspberry Pi 0, then the cables will go up and around. Right here we'll have Pico. Pico will control a bunch of peripheral devices, whilst the 0 will go onto the other side and will control more complicated devices. So right here we'll, for example, have a 7-segmented display, and possibly an I2C OLED screen. That might be it. Also, a microphone would be really nice to just add in there, like so. I feel like that would fit in pretty well. And that will all be controlled by a Pico, which will do like very basic processing of the signal. When I say very basic, I mean like mostly packaging and parsing, and then it will travel through the cable to the other side, where the Pico will actually interpret it and handle it in different ways. So the 0 will be, did I say Pico? I meant 0 if I said Pico. The 0 will be like the main brain of the operation, and then the Pico on the other side will be kind of like a multiplexer of sorts. Like a very special make-it multiplexer. Another sip to get the blood flowing. Right. Okay. So, and yeah, and now that SolidWorks turned on, this is what the newest mask looks like so far. I have printed out all the parts, so right here you can, for example, see this one. I have printed all of them out, however, I haven't assembled them yet, because the outer skeletons, right? They're once again also printed, waiting in the corner of my office. I just haven't gotten around to assembling it. This is a different method because this is just a modular plate, which, long story, doesn't matter. Irrelevant for now. For now, what is relevant is this. Is it? Rube Goldberg machines. That's not a good start. That's not a good start to the project. Is that part of the HUD? I would love that part to be for the HUD. The problem, Adrian, is that designing a HUD is actually way more tricky than it seems. Because you need to like... Designing it properly is very tricky. Because you need like... Usually a projector system. That's because your eyes can't really focus well on things this close to your face. So that's the tricky bit. Like, make it, man. A man! Come on. I am both that. What are those? Let me see. Stack Overflow! Oh, the great start. Okay, that feels like... my cereal. That looks like a USB. What I really want is I want it to function using the pins. That would be swell. So the basic idea I imagine would be that we connect right here. We just take 2 pins, some kinds of pins, so whatever. Pinouts. Like this, and we do have 15. What's the word RX actually? May I have a chemistry project idea? Make wood alcohol. What do you mean by that? Function universal asynchronous receiver transmitter responsible for receiving serial. Oh my, that sounds like something I'd be interested in. Transmitting what converts power. Okay, that seems setting like something I'd be interested in. What can Raspberry Pi Pico handle that as well? Yeah. Can you? What serial appears so? Right here we have TXRX. So like TXRX. So if we do this, and then TX, does TX have to go through? The point is we connect these two and then these two, and that could achieve communication. Oh, maybe. Google wood alcohol. With all due respect, Olo, the second so anyone tells me to Google something they are suggesting me to do, my interest drops. Okay, so we have a packet. Oh, that is great. I really like the Circuits Basics website, by the way. I think that's a great website because I've already seen the website for the I2C protocol and it's been the same way. It's just phenomenal. Directly Vitroda. Okay, so TX to RX, TX to RX. That makes sense, which means we get Raspberry Pi Pico TX RX, TX RX, which means we just plug them in backwards. There we go. Right here, orange goes TX to second RX and TX to RX. Perfect. So this will be just a single double string connection between them, which is neat. Okay, and then the transmitting unit converts parallel data contained about the CPU to serial form. It transmits it in serial to the receiving UART, which then converts the serial data back into parallel data for receiving device. Only 2 wires are needed to transmit data between 2 UART. Data flows from the TX pin transmitting UART, the RX pin the receiving UART. Okay. There is no clock signal to synchronize the output of the clock signal transmitting UART adds start and stop bits to the data packet being transferred. These bits define the beginning and the end of data packets, and the receiving UART knows when to start reading the bits. When UART detects a start bit, it starts to read incoming bits, predict frequency, known as baud rate. That all makes sense, yeah. Okay. So there we go. Which means this is already quite descriptive. I like it. Let's try it. Quasi is more fun to hang out with than make it Timon. There we go, this one. Okay, so you need to enable UART, right? That much makes sense. Now, how do you use it? I imagine it would be with wiring Pi, if I had to guess. I remember the pinout website was also quite great. That's because right here we had this word. Wiring Pi. Okay, that's quick. Shucks. Alright, well then, without any further ado, let's try it, I suppose. By connecting this to power. There we go. It's connected, which means now we need to wait a second for it to boot up. Have a Pi 5, but using a CM5 for a video audio processing would be more fun. What's a CM5? Okay. Go. The LED is still flashing, which means it's still booting. So I need to wait a little bit more. And in the meantime, we might as well plug in the Raspberry Pi actually on the other side. Like this. There we have it. And then we just go into the terminal, CD desktop projects, and do the thing. Surgery, then whatever. Don't save, doesn't matter. That's because right here we're gonna do a new project. which will be new MicroPython project, and then it will be UART, and then right here UART create. Splendid. Compute module 5, the CPU RAM on a small module. Compute module 5. What is that? Compute module. Oh, it's just compute module. That's it. That'd be great for downsizing in the future. I could just cut it out of the Raspberry Pi 5, you know? If I'll ever try to downsize in the future, that would be useful. Okay. We have the Blink Pi, which is not what we're going to use. Instead, we're going to, first of all, do SSH, make it at 192.168.108. And then, is it this one? I don't think it is. If it takes that long, that means it's not. There we go. Sweet. Make here what? Actually, first what we need is we need to enable it, which was sudo. What was the name of the command? Sudo raspberry pi config? Raspberry pi config. Raspi config. There we go. Sudo raspi config. And then what we want is system options. No, not system options. Only we want interface options. Right. 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 That's absolutely not the way I mean it, no. Oh, it's just serial port. Okay. Let's try it. Serial port. Splendid. A login check because over. Yes. Yes. I think that would be it. I think. Now, how do you do UART? You do it like this. Okay, now what we need is we need MicroPython UART. Because then, this is what will be receiving the data. And we want to run it on... the Pico and try to receive data on the Pico. If we do that, that's actually... Well, that means it works, which means the rest will be just coding around it to actually make it fit. Good, splendid, festive, fantastic, lovely. Okay. Let's try them. I mistyped again. I mistyped again. There we go. CD ports and then list. Nothing there. That's okay. Right here, instead of having Blink Pi, we're gonna have from machine import what, and then we're gonna just do this. What is your buffer? Sorry, what is your buffer? Because you're reading it. Then it's a byte object. Okay, so what? Do I just need like a buff is equal to nothing and then buff is equal to read 10? Can I print this? And then you. Oh, that's using Python. I just hit me. Uh-oh. I should have Python, correct? Oh, splendid. Alright, let's try it then. What are we waiting for? From machine import what? Okay, import wiring pi quit pip install wiring pi. Right, sudo apt install python 3 wiring pi. MVP, make it wireless protocol. Unable to locate the package. I am gonna lose my mind. Wiring pi. Wiring pi Python install. Why can't you find the thing? Can I just sudo apt install Python pip? Or do I need to do it without the 3? Never mind, I don't need to do it without the 3. Oh, I'm sorry. I was making a VPN because it's banned in my. I am banned in your country. Oh my goodness, I'm moving up the world, aren't I? Okay, that looks better so far. The other side you have from machine input. What? Then 19600. We've given baud rate. Okay, got it. What? Limits 9600. And then bits is equal to 8. That feels fair. Parity none. Stop 1. Okay. Given parameters, that all makes sense. And then we can try. If we try what read, it should give us nothing, correct? None. Okay. So far that makes sense, I think. Although I don't like how quickly it returned nothing, because that kind of got me worried a bit. We'll need to implement our own system for it that double checks everything then, I suppose. Like we keep sending ones and ones and ones and ones until we get a response, and only once we get a response we start the communication. And then install could it? Oh. But this doesn't work. I hate this. I need to create a virtual environment. Why? What is the wiring pipe? Oh, because it's wiring pipe. Oh, so is it wiring pipe too? Because we're on the Raspberry Pi Zero. No. Okay, well, over try. Could it be wiring Pi? No. I am gonna lose my marbles. Python M3 verb to create a virtual environment, but I don't like dealing with virtual environments. Because when you do virtual environments, then you need to keep track of everything. Keep track of when you are in a virtual environment, when you're not. Alright, fine. Now we're just trying it out with. To be fair, in the end, we will do it with C anyway. And it just died. Oh no, it is writing. Okay, I can see the LED flashing. There we go. It just hit me. I just got a Windows error sound. I don't know where from. I got it from somewhere. Bricklock acid truck for you, for you. I need to be logging bricks, yeah. Just in case there is a brick in my code, I need to know. I swear, if this won't work, I will be just upset. That's it. I'll just be upset. Okay. Because so far I'm trying it with Python, because the whole point is that I want to try doing Python so that I can make sure that it works before actually doing anything with it. Actually, no, wait. Import wiring Pi. There we go. Now, what was the UART solution here? Okay, it was oh, but we don't know if we have it. Okay, so quit real quick. TTYAMA. Wait, how do we know what? This okay, which device would it be? Did I enable it? Port. Zero hardware port. Yeah, okay. But then where would the thing be? Device. What device? What device? USB, by the way. So wait, hold on. Which device would it be? Which one of these suckers is the UART device? Oh. Would you have an answer for me? LS USB. Oh, that's actually smart. One. Wait, which one is device? Which one is that? You're looking for what pins? Yeah. Shit. Connected to a background, some magic blue smoke. 2 watts. Right, but I don't have a 2, 3, or a 4. I have a 0. All pins are the same for Raspberry Pis, I thought. Yeah, but I still need to know which device is the UART device. I still need to know that. Actually use it. So TTY, right, processor, TTY, driver, serial. Permission night, that checks out. Yeah, I haven't, doesn't really help. That does not in fact help. TTYSO, is it? You know that? How do you know it's TTYSO? Is the 0 in front that tells us. What? This? But how do you know it's TTYSO? Or is def TTYSN where... Oh! Well, thank you, Kava. So, I appreciate that. TTYSO, okay. Back to Python. Because what we need is we need imports y1 pi, then y1 pi, y1 pi setup. Right. Okay. Okay, also love the error starting with oops. That's also sweet. When the script tells you to go, you know it's really bad, yeah. Never thinking that the system can find necessary hardware. I guess that, yeah. Version 2.52 of Wiring Pi was deprecated by the author in 2019, but it still works. At least on the Pi was available at the time. It's deprecated? Well, that's a fair bit annoying, innit? That is certainly a fair bit annoying. Oh. Because that would make sense. Yeah. Okay. Quick question. Raspberry Pi 02W. How do we make it happen? Because what am I supposed to? I can do it with wiring pi. I guess wiring pi h. Yes. I guess we need to do it with C then. Fun. Is there a? The documentation for this is killing me because there isn't much. But is there anything about UART? No. Damn it. Graphic is very descriptive. Must be playing version 2. Yeah, shit. Okay. Use wiring serial, by the way. Is that something that's by default, or is it wiring serial H Raspberry Pi 0? Is that by default? Or is that not the library? This part of wiring pi! Splendid! Oh, splendid! Serial open, serial close, serial flash, serial put, serial put, serial print. Oh, that is all lovely. Oh my goodness, yes. Examples. Serial. Serial test. Serial read. Oh, how lovely. Okay, we're going with C. Because I cannot even. Why is it int fd? That just bugs me a bit. I'm not used to seeing int be used that way. Okay. Deactivate. Splendid. Sudo vim test C. Right. Can I just copy all of it? I'm not gonna lie, that would save me some time. Splendid. It's actually cultural appropriation of British culture, say in it. Okay, hold on. I'm getting hungry because of this. Okay. So right here we open up SO. Then we do wiring pi setup. Then we do all of that. What about this? There we go. Okay. Quick, print something. Right. Test. Shit. Did I get something screwed up? Okay. Quick question again. Did I... Oh my goodness, not what I meant. This is what I meant. Did we do everything correctly? Serial open. I'm guessing. I have to guess because there isn't any documentation for it. But I'm guessing serial open. I need to open up like the. Not the examples. Only the actual source code. Because the source code just gotta have. That's from wiring. Hold on. Serial. There we go. There we have it. GPM read all for Python. No, I'm sticking with C at this point. Serial open. Okay, this is the baud rate, so that could be screwing us up because the baud rate we had was completely different, which means that we just need to go up 9600. Now we can try it again. Okay. On Tuesday I went to work today again and I've heard nothing about. How do you accidentally skip work? What happened? This. Then wiring pies. Print. Where's the count? Count is 0 counts from this. Wait a second. No, get charge only happens there. So we actually want to comment all this out, don't we? Well, actually, easier than commenting it out, we could just do and 0, which is easier. Shit. Okay. So we did, that did work for the if. Then delay, oh why delay 3? Wait no, that's 3 milliseconds, isn't it? Yes, that shouldn't be too bad of a deal, but we're still gonna make that. Then we have while serial data available. Oh, that's why you delay 3. No, that makes sense. That does not give us a lot of time, that gives us like a second. Can I do delay 10 or 30? It just hit me. What if the issue is on the other side? This should be simple to check. Well, simple-ish. There you go. Okay. Yeah, you may consider it dumb what I'm doing right now, but it should work. Is that the receiving? That could be the receiving. Okay, never mind. It did not in fact work. I was hoping we'd see it really swiftly flash. That was tempting. Would have been nice if it worked. So we can't even test if it's outputting correctly. Because, or maybe we can and maybe we just did, because there's a possibility that right here, into a given baud rate, when we set up UART, we set it up with a proper number, right? And Raspberry Pi Pico, one thing about it is, if we look at the pinout, then I'm pretty certain we're connected to UART 0, not UART 1. Yes, we are, which means we should do a soft reset. Like this. And then next. And then this, hopefully, would work. But once again, the same exact issue we had before. Which means no clue if it works. I mean, right now it should be working. That's something. I plugged them into the wrong pins. Damn it. Come on. Should be working. I mean, I agree that it should be. Does it though? That's the question. Okay, if I do remember correctly, we had to flip them around. So, like this. Now let's see. I knew this live stream was gonna be fun. So basically, I need another sip. I can't deal with this. Oh, okay. Okay. Why? Why, oh why? Let's add some more prints. Print. Run in there. I'm sorry. I did print, didn't I? Obviously print. No. There we go. I cannot even. I did the second one in Python because I'm doing it in Python and C at the same time. Okay, so that makes sense. This told us quite a lot. Well, I mean, it told us the same thing we were expecting, but you know, confirmation is always nice. Because it basically just told us that we are not receiving anything. Good! That's great! Why? Spotify saying goodbye. Goodbye, Adrian. Goodbye. Have a good one. Show me more. I am curious. Simple way for me to test that somehow. How can I test that? How can I? Did I initialize? Yeah, I did initialize it. Sample code would be make sure that out too much. Yep. These are all great graphics. Absolutely love them. Oh, you do create an instance of a polling object, register system, monitoring read events with priority 1. Oh, read 1. Check. Okay. That makes sense. I like that code a lot. I like that code a lot. May we run it? But it just hit me. Then we need right here for it to not be receiving, we need it to be transmitting a T once more. So we go in and we enable this if. Disable this one. Right, and then we put char account, which ain't too bad because right here what we can do is we can just do password C and then just do the count again, because that is what we put char, which means eventually we will get to a T, and that should enable. That sound was a bell, wasn't it? That sound was a bell, okay. Alright, neat. We're going through all the different characters and we reach a T. We should have set up this code in a smarter way so we don't actually have to loop through every single character in ASCII. Oh well, too late now. Well, that was fun. I think that would be the word to describe it. What if? Ha 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 ha. Let's double check the pinouts again because maybe I plugged them in backwards. So we plug in the 0th pin of Raspberry Pi Pico to the 5th pin of Raspberry Pi Zero. So yellow has to go from the 1st to the 5th. That is correct. Orange, that's also correct, yeah. Shit. Damn it. Damn it, damn it, damn it. Damn it. Now what? Well, now it's checking for TY. Why TY? Why not just T? It's specifically checking for TY. Why don't we just modify it to be a T? And then we go in here and we edit a bit so that instead of starting, that will be count plus 64 to speed it up a bit. I don't remember exactly what the offset is, so we're just gonna deal with 64. Yeah, not too far off. 96, I suppose, would do the trick. Alright. I don't know why I didn't think of that earlier. To print the character we're receiving. It just seems kind of obvious. Yeah, so we're not receiving anything. Good. Good. Great. This again. Alright. Let's try these out. We have this 0 open, right? Oh yeah, but you did open up, so that's great. All of this works splendid, just great. Then right here, I just realized that the UART we're using Oh. Oh, I think that would be a problem. If I change this to 0, I'm gonna close that now. I just like. Now, if I run it. Because this one is running proper, the left one. This one is fine. This one is the problem. I know some Temu breadboard ad during a charity checkup. Okay, stop this one, stop this one. What if we do this? So MicroPython works. Let's see. Sample code, basically. That's what we want. We want sample code. No, this is the one we're using. Shucks! Wait, do we want to use the... Because it should also use the USB as the UART, shouldn't it? Yeah, hold on. Is this the right device? Wouldn't USB be the SO? I feel like the USB would be the SO, wouldn't it? Cat showed an UART device. Did it? Shit, what's the... It is, you are correct. Well, then on this side, it must be going well, which is bad. Hold on, I just realized this side is sending, so may I please try connecting this to ground? Just to see. Just to see if we could get an LED to blink. This one, yeah, right, that's proper. Yeah. This, splendid. Right here. My dishwasher just turned on all of a sudden. Okay. Now, if I run this, we get nothing. But what if I plug it into, because this could be the receiver. Holy shit. So this is sending. I think, if I stop it. That's still glowing. That's pretty bad. Or is it? Wait, is it TXRX? Because I'm pretty certain RX stands for receiver. And TX stands for... Yeah, I know, you can shut up now in the background. Note, is this the one? TX and RX. The orange one should be... Shouldn't that... No, that is the transmitter. Never mind. Okay, yeah. So that's Always on. Not a great sign at all. Okay, well. I mean, at least we can guess that it's transmitted now. Damn it. If I were to send just zeros, shouldn't it just start dim? Not what I meant. I meant sudo dim. What if I ask you to just send zeros? I know that I am testing like a caveman, but well, I don't really have any other idea on how to test it. My only idea is that we go right here, and if count is, we multiply it by a logic statement of count smaller than 32, and then for the initial ones it should be a 0, and then it should jump up all of a sudden, which would mean that it should start dimmer, and then it should okay. How can we test if our device is sending out? We could test it with a Raspberry GPIO, I suppose. Couldn't we? I do believe we could. I do believe we could test it with a Raspberry GPIO. Yeah, if we just set up a loop that constantly prints the input on a input on a pin. Right. Imp is equal to pin 0 pin input. Pin. There we go. Pin pull down, I think. I have no clue. Print imp value. We have a 1 constantly. If I plug you in, we can have 1 constantly. Ah, oh, my head's. Okay. So, is it pull up or pull down? And is it even the value function? Or is it something else? Like if I just plug the first pin directly into the juice, what are you gonna give me? A 1. If I plug it directly into the ground, what are you gonna give me? A 1. You see, that's not a great sign. I don't want to deal with this anymore. For everyone, it always shows AMA0 as a neural connection. I don't, and I'm kind of worried. Like right here, there's another one which shows serial dev TTY MAA0, and that is for a Raspberry Pi 02W. Unless this is ND3 Pro, is it? No, wait, this is different. Never mind, take it back. Well, you should add more pins on your printer controller. Free. Raspberry Pis are not 5V tolerant. You'll kill the GPIO pins if you apply 5 volts to it. That's good to keep in mind. Board has enough current power pressure. Oh, power up. No, that's not what we really need. What is one way? Sorry, what? Primary is a 1. On the Pi 02 is a def 0. Is it now? That's Pi 02 to be fair, not Pi 02W. Secondary on the Pi 02W. Wait, so UART 1 is the where is this image from, by the way? That's quite useful. Where is the okay? So Raspberry Pi 02W primary one would be UART 1, right? Okay. But that would mean I need to move the pins, wouldn't it? But then why would it? No, that doesn't make sense. And the pinout, I am so confused. Raspberry Pi 02W, just data sheet. Give me all the data. That's not a lot of data. I need more. I would really like more data, please. I would really like to have, okay, two schematics, mechanical drawings. Neither of those I need. We have like notes. No. 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 Maybe? TXD, RXD. Right, those are the pins we're using. Those are the pins I'm using. I am so close to losing it all. We could try SPI, I suppose. That's what I was gonna start with, wasn't it? SPI. Okay. Raspberry Pi 02W SPI. Let's try it as well. Oh wait, no, the Pico pinout website. Pi 02W pinout. That website is always a neat start. Where is it? There we go. Pinout XYZ. What we want is we want SPI. 4 wire serial bus. SPI lets you attach multiple devices to a single set of pins by assigning them a different chip select pin. This is the one we've used for the controller video, the Grid. I am developing such a headache. Okay, great, great. I would need to enable it again. Oh, didn't even need to restart. Great, sick. Cool, so we have this. What's next? We have it enabled. Now, wiring pi. Just go on GitHub. It's gonna be easier for me to just find the examples. There we go. SPI. SPI. One of these has to be SPI. Speed? Okay. Wiring pi SPI. Yes. 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 Okay, we have the so far. Alright, now let's go through it. I just need a deep breath. Okay. So, we have SPI setup. Iron by setup, SPI channel speed, small. Okay. This makes sense. This does make sense. Can open SPI bus and then we get the error. Right. We input the screen. The channel is 0. Important to keep in mind. Hi Dimitri, by the way. Hi. Then main speed times size, we just create all the variables on the very beginning. Lovely. And we have our data as an unsigned child pointer. Once again, makes sense. Lovely. Then we malloc the data. Obviously, don't want to lose it. Then wiring pi setup to set it all up. After that, what we do is we do speed times however times a million. I imagine that's because speed, yeah, you wouldn't want to do it too many numbers, that makes sense, okay. And then we just go over all of these. Print speed and size, I don't quite understand. Oh, it's because it's going over all of them. Oh, right, that makes that makes sense with the speed. Okay, yeah. Wiring pi SPI data read write, I am guessing is what it means. Because then SPI span, that's channel, I'm an idiot. SPI channel, right, 0 channel. Then my data, that would be the data to read. That's why we're giving a pointer, that makes sense. Then the size, we just loop over it every single time, because in this case, okay, so size is the one that reads, okay. I am a bit confused about what RW means. I could just go into the the library again and just read the source code, because I don't really see any other way. Which means, I'm sorry, wiring pi SPI? Where is it? Wiring pi I2C SPI. Okay. And H actually would be convenient just to see what kind of functions we've got. Well, what can we deal with? Okay. So we've got getFD, makes sense. Oh, that's interface 3.5. New. Okay, let's go with this one then. That the same one just has an X. That makes sense. So we have a setup in which we. What is the number? The channel I can get behind. What does the number mean? all of these have a number. One reply setup, then we have, where is it? SPI setup. That's not even my reply SPI, that's just SPI setup. Oh, because of this one, okay, that makes sense. So the channel is the number. No, right here we all have they all have numbers. What's the difference between the number and the lack of number? How do you use the number? Oh, that's the number of the SPI. Okay. I'm with you. I'm with you. Because then it would be SPI dev. Again, so maybe it's SPI dev 00, SPA dev 01. Okay, with you so far. I am developing such a massive headache. Oh my goodness. I call it burning my electronic, I call it caramelizing. Okay. Okay. Alright, okay. I think before I am I genuinely think I need a break from this. I'm developing quite a big headache. I need a break. I cannot even. That was a fun live stream. One more sip before I go. I am gonna. Last stream I promised that when I find something different than I2C, I'll start the stream, and I did. But I'm not gonna do another one of these trying to connect the two Raspberries together live streams because they suck. So instead, I'll just try to connect it myself. And if I succeed, then the next live stream will be about integrating them into the mask already. And if I fail, then the next live stream will probably be about Boti and making an engine. Because... Thank you, Theo. I appreciate your support. I do. I need a lie down. That was a live stream, certainly. Anyway, I genuinely do apologize for the live stream sucking so much recently. Because I've just gotten to a really boring part of work. Once I find something more exciting, then we'll pick up, but yeah, no, it's all good. Thank you, Mitchell. Thank you, I appreciate that. But no, I genuinely do feel bad about doing stuff that is boring, so don't worry. Soon we'll get back to exciting things. And for now, I suppose that'll be it. Thank you everyone so much for watching, and have a great day. Bye!